In problem number 7, we're given a function s of x which describes the number of sales, the number of units of the product that will be sold if x $1,000 are spent on advertising. So this function tells us how advertising helps the sales. And the question in the problem is how much should be spent on advertising to maximize the revenue. In mathematical terms, basically the question is what value of x will produce the largest possible value for s. S is the sales. And so what we need to do in this problem is we need to determine the maximum, absolute maximum of this function s of x. More specifically, we are interested in the x value that will, when plugged into this function, will produce the largest possible value of this function. Okay, so just like we did in previous problems, we will begin looking for that maximum point by calculating the derivative of this function and setting that derivative equal to 0. We want to do this so that we have critical points for this function. And the reason we need critical points is because the maximum or minimum value of a function is always reached at a critical point or at the endpoints of the interval that we're looking at. In this case, the no interval is given, so we don't really need to worry about that so much. We need to concentrate on calculating the critical points. So first step is to calculate the derivative. This is fairly easy. We differentiate term by term using the power rule, and we get -2 times 3x squared. And we have plus 27 times 2x plus 132. And the last term, 207, that is a constant term. The derivative of a constant is equal to 0, because when we change the value of x, the value of that constant does not change, and so its rate of change is 0. Let's simplify this a little bit. We get -6x squared plus 54x plus 132, and let's set this equal to 0. And now to solve for x, factor out the left hand side of this equation. So first of all, we can factor out -6 to get -6 times, in parentheses, x squared plus 9x. Actually, I just made a mistake. It should be not 9x, it should be -9x. And the reason it should be -9x is because I'm factoring out -6 out of positive 54. Essentially, I'm dividing positive 54 right here by -6 that I factored out. And so the result is -9. And then we're going to have negative 132, this term right here, divided by 6, -6. And so that's going to be negative 22. Yeah. Okay. And then the quadratic polynomial x squared minus 9x minus 22 can be factored further as x minus 11 times x plus 2. The way to see that is to note that the constant term in the quadratic polynomial, -22, factors as for example, negative 2 times 11, and negative 2 plus 11 gives us the coefficient of the middle term, negative 9. Okay, and so our conclusion from here is that this function has two critical points, negative 2 and 11. Now, in this problem, the value of x is the amount spent on advertising. It doesn't make sense to talk about negative expenditure on advertising, so the negative values of x do not make so much sense for this particular problem, and we will concentrate on positive values of x. So there is only one positive critical point, that is x equal to 11. This is most likely the point that we're looking for. That's going to give us the maximum amount of sales. But we need to confirm that because it could have been, for example, the minimum. It's from the analysis that we've done so far, we don't really know whether x equals to 11 gives us the maximum or a minimum, or it could also happen that it's neither maximum nor minimum. And so to verify, to confirm that x equals to 11 is indeed a relative maximum, what we need to do is we need to draw a sign diagram for the derivative, as we did for other problems. Okay, so let me see. Okay. Here's the information that is relevant. I'm going to draw the number line, the x-axis, and I'm going to mark the critical points, negative 2 and positive 11. And we don't worry about the integral from negative infinity to negative 2 because that's negative values of x, and though they are not relevant to our problem. And so we just need to look at the second integral and the third. Let's use our test point. We can use x equals to 0 as our test point on the second integral. I'm going to use a different color to indicate the test points. So let's say 0 is, well, actually it's somewhere here probably, right, if in terms of the scale. And then we can use maybe 12 for our test point on the second segment. So if you plug in the value of x equal to 0 into the derivative, you're going to get that it is negative 6 times 0 minus 11 times 0 plus 2. I'm using the factored out form of the derivative, and I don't really need to calculate the value itself. I just need to know whether it is positive or negative, and it's easy to see because our value of the derivative at x equals to 0 is a product of a negative number, negative 6. Then there is another negative number, 0 minus 11. And the third factor is positive. So since the product of two negatives is a positive and the product of two positives is a positive, that is greater than 0. And so that tells us that the derivative of our function, s prime of x, takes positive values on the entire second integral. Even though we tested this derivative at a single point on the second integral at x equals to 0, nevertheless, the conclusion about the values being positive applies to any other point on that second integral. And if we plug in x equals to 12 into our derivative, we will get that that value equals negative 6 times 12 minus 11 times 12 plus 2. Again, I will not bother calculating the number itself. I'm just going to look for whether it is positive or negative. And we'll see that the first factor here is negative, second positive, and the third is positive. And so overall, this value is going to be negative. And that tells us that the derivative of s of x, the sales function, is going to be negative on the third interval. And so if you're thinking about the graph of the function s of x itself, I wish I had more space. Let me actually redraw this picture. Just let's say x-axis, and I'm going to draw the vertical s-axis for the sales. There will probably be some sales even if x equals to 0. There will be some sales even if the product is not being advertised. But then as x begins to increase from 0 to 11, the derivative of the sales function is positive, so we will see the growth in sales. And then as we approach x equals to 11, the graph becomes less and less steep. It becomes horizontal at s equals to 11. And then since the derivative becomes negative as soon as we cross to the right-hand side of 11, the sales will begin to decline. And so this analysis tells us that at x equals to 11, the sales will reach their maximum value. So this is the absolute maximum. It is, of course, also a relative maximum, but in this case it is not just a relative maximum, it's absolute maximum. Because we see the value of the function at this point is the overall largest value, at least for positive values of x. So that is our answer. X equals to 11 gives us the largest value for the sales.